We have completed the construction of the trousers, and all we are left with is applying the materials. In this lesson, we run through the process of materializing the trouser according to the specification sheet and refining the simulation. We highly recommend that you try materializing and refining the trouser first with the knowledge that you have. Then, use this video to verify and review. If you'd like to try it out first, pause the video now. We start off by applying the right fabrics to the garment. We look at the fabric specification. The main fabric we are using is a wool lightweight. We downloaded this from the Browseware Cloud library. We search for the wool lightweight fabric and check that it has the correct composition of 100% wool and that it is 292 grams per meter square in mass. According to the spec sheet, the fabric should have an all-over print as a diffuse map. The all-over print is available in the Materials folder, which you can download from the downloadable area for this lesson. Once we have downloaded the folder, we click on the diffuse map of the wool lightweight fabric. We replace the existing diffuse map with the all-over print. The diffuse color needs to be reset, as we want the true color of the print. Before we assign, we need to remember that there are patterns for this trouser that would have been constructed with 2 layers instead of 1. For example, the waistband and belt loop patterns. Therefore, we need to create a clone of the fabric to edit the physics to be doubled. Once we have cloned, we can rename the new fabric and add DBL at the front to indicate that this is a double layer fabric. We click on Physics and adjust the values. The mass, thickness, stretch, and shear values need to be doubled. And the bend value needs to be multiplied by 10. Now we apply the double fabric to the patterns that require it. The waistband patterns, the belt loop patterns, the pocket flap and welt patterns, and lastly the fly pattern. Then we assign the original fabric to the main leg patterns and pocket facing. Switch to the inside mode on the 2D window and assign the fabric to the attached facing on the back pocket bags. The pocket bags use a polyester fabric, which we need to download from the library. We look for a polyester fabric which is 100% polyester and 185 grams per meter square in mass. Once that is downloaded, we assign the fabric to the pocket bag patterns. We need to adjust the color. According to the specification sheet, the RGB code is 150, 93, and 57. We allow the garment to simulate with the new fabric physics. In the specification sheet, it states there are parts of the trouser that are fused with a woven interfacing. The interfacing is available as a U3M in the Materials folder, which we downloaded previously. We add the U3M as a fabric. In the 2D window, we do not have fusing patterns, so we need to create them. Let's look at the specification sheet again. According to the sheet, the following patterns need to be fully fused: the waistband patterns, belt loops, pocket facing patterns, fly, and fly facing. For these patterns, we clone the original patterns to create the patterns for the facing. For the fusing that is added to the pocket opening, we create them using the Insert tool. Let's get started. First, we clone the patterns that are fully fused. We clone the waistband patterns. We clone the belt loops. We clone the pocket facing patterns and fly facing. Next, we need to create the fusing patterns for the welt pocket openings. We start with the front pocket. We click the hole, then do a clone by offset of 1 centimeter. This creates an internal rectangle. We need to convert this rectangle into a shape. The internal lines are not a closed shape yet. We look for the opening on the rectangle and join the points to create a closed shape. Now we convert the internal line to a shape. We do the same for the back patterns. We can assign the interfacing material to all these patterns. The next step is to align the fusing patterns and attach them. Once attached, we move the attachment to the inside. We repeat this for the rest of the patterns. For symmetrical patterns, you can use Magic Mirror to attach the fusing on the symmetrical side. We allow the garment to dress. The fusing can be seen in the 3D window. To hide it, we can adjust the transparency of the interfacing material. If we still see a floating shadow, this is due to the thickness of the interfacing. To resolve it, we adjust the thickness of the interfacing to 0 centimeters. Now we can start to apply the seams on the trouser. Let's have a look at the spec sheet. We need to create 3 different single stitches, 1 double needle stitch, and 1 bar tack. In V-Stitcher, we add a single needle. We adjust the stitch workmanship. We adjust the offset to 0.25 centimeters, thickness to 0.04 centimeters, space to 0.02 centimeters, and SPI to 9. The other single stitches have the same workmanship values, except for the offset. So we clone the seam twice, and then adjust the offset value. At the same time, we rename the seams so that it's easier for us to identify them. The next seam is a double needle stitch. We add a double needle stitch into the seams. Then we adjust the workmanship values according to the spec sheet. Lastly, we need to create a bar tack. To create a bar tack, we use a zigzag stitch. Then we adjust the SPI to 50 and adjust the width to 0.2 centimeters. The thickness can be adjusted to 0.07 centimeters. We rename the seam to bar tack. When assigning bar tacks, we add internal lines to the patterns and assign the bar tack to those internal lines. We start assigning the seams according to the specification sheet. For the rise of the pants, we are assigning the seams to only one side. To do so, remember to disable Assign Seam to Symmetrical for the pants patterns. For the bar tacks, we use the pen tool to add the internal lines. Then we assign the bar tack seam to those internal lines. Continue adding the internal lines and assigning the bar tacks as specified in the spec sheet. The last step is to change the color of the seams. We adjust the RGB values for each seam. Remember that we can save a custom color in the palette and use it for the other seams. Done. And we can now add the trims to the garment. The zipper has already been added, so we just need to add the button and label. For the button, we use a plastic button that is paired with the keyhole buttonhole. We look for the right Smart button in the Browseware Cloud library. We download the Smart button. We need to adjust the size of the Smart button to 2 centimeters. The buttonhole needs to be 3 centimeters in width. We assign the button to the waistband patterns. There is another button that needs to be attached to the inside of the waistband. After assigning, we move the button to the inside. Then, we adjust the buttonhole rotation for both buttons. The buttons are not sitting correctly on the buttonhole. To fix this, we select the diffuse map of the buttonhole. We need to remember the size of the button. It is 18%. Now we click Edit to edit the buttonhole in Photoshop. In Photoshop, we add some space to the front of the buttonhole using the Crop tool. We save the image. In VStitcher, the buttonhole image has been updated and resized to the original size. In the image editor, we adjust the size of the buttonhole to 18% again. Then we look at the 2D window and adjust the crop region to the buttonhole image so that the dot sits in the hole of the buttonhole. We need to adjust the color of the Smart button. Both button and buttonhole use the same RGB code, so we select Single Color before we change the color. Next, we add the label into VStitcher as a piece assignable trim. There are 2 pieces to the waistband, so we need to assign the label to one side of the waistband. We adjust the size of the label to 5 centimeters by 2.3 centimeters. Then in the context view, we select Cross. Then we center the label. The final step is to refine the trousers. This includes that the styling is as intended, adjusting the grid size, and checking that the materials and stitch construction used are suitable for rendering. First, we adjust the stitch construction of the edges and internal lines. We can use the V-Ray preview window to check the effect of the stitch construction. If using a directional seam type, we also need to adjust the direction of the stitch construction. For example, for the waistband, the stitch type should be a directional stitch as the seam allowance of the leg patterns is folded and ironed inside the waistband in a physical garment. The extended waistband is now using the flat type of the stitch construction, so ensure that is also adjusted on your end. We continue adjusting the rest of the edges and ensure that the depth for the stitch construction is also suitable. For lines like the J-stitch, we can use a flat stitch construction. If we want to have a slight dent, we can use the open seam but adjust the depth to be lower. We can play around with the values according to the visual effects that we want to achieve. We can also adjust the displacement values of the stitches if they are too high. Next, if required, we can add force multiplier to edges that have multiple layers stitched together to reinforce them. For instance, the waistband and the belt loops. Remember that the amount of force multiplier we add would depend on the number of layers that are stitched into that edge. The depth would be the same depth of the seam allowance. In the technical drawing of the trouser, there are crease lines added to the front and back pant leg. To do this, we need to add an internal line on the front and back leg patterns. We turn on the grain lines and use them as a guide to the position of the lines. Once we have added the lines using the pen tool, we select the lines and select the iron property. We can input 90 degrees for a crisp crease. Then we allow the garment to simulate. If needed, we can adjust the length and position of the iron line. Next, we need to adjust the grid size for the patterns. For larger patterns, we can adjust the grid to 0.7 to 0.8. For the smaller patterns, we can adjust the grid size to be much smaller. For instance, the pocket and welt patterns, waistband, and belt loops. Here we can use values between 0.3 to 0.5. Once we have adjusted the grid, we allow the garment to simulate to accommodate the changes of the grid sizes. We use the styling tool to pinch out areas that are not sitting nicely. If needed, we can use the hold function to certain areas to ensure it stays in place. We use the V-Ray preview to check if there are any collisions. If we see collisions, we can try pinching these out or reduce the grid size. And we have completed the trousers. Now you can try and create a ray trace render output. Apply what you have learned in the rendering part of this course. It is good practice, remember, to clean up the file by deleting unused materials and screenshots. For more information, visit our help website.